So, in our last lesson, you learned all about the Pythagorean theorem and the relationship between the three sides in a right triangle. So, do you still remember it? It was a squared, a as one of the legs, plus b squared, another one of the legs, equals c squared, and c as a hypotenuse. So, a squared plus b squared equals c squared is something that is very important later on geometry, and also you should be able to use it backwards too. So you should know that b squared equals c squared minus a squared. Once you see c squared, you know it's a squared plus b squared. All types of things like that, not just left to right. So in this lesson, we're going to be proving the Pythagorean theorem. Understand and prove why the Pythagorean theorem is true. So learning about the Pythagorean theorem also includes being able to understand why it's true and answering questions about it. Like for example, later on we're going to be doing, does it have to be a right triangle? So those are all ways of understanding this concept. So, 2 learning goals for today. Learn to use several methods to prove the Pythagorean theorem and is able to use the Pythagorean theorem to solve simple problems. Here's an introduction, and I want you to observe and think. Activity. Please use the 4 congruent right triangles below to make a square with the hypotenuse as a side length. And I want to remind you that the hypotenuse is this side right here, hypotenuse. So going ahead, in your notebook, sketch all the different ways you could use the hypotenuse to make a square, and I'll be right back. So what did you come up with? Well, are there different ways or just one way? So, proving the Pythagorean theorem. We learned about the Pythagorean theorem in the last class. Do you remember its rules about right triangle? So, how do you prove it? According to incomplete statistics, there are more than 400 proving methods. Do you have your own proving method? If so, please tell us in the comments down below. So, one would be Pythagoras' proving method. So, Pythagoras took the triangles and he set them up in this shape, and these triangles are all congruent. So first what he did was he tried to express this large blank squares area, which would be the sum of a plus b squared, or c squared plus 4 times 1/2 of ab. So these are all ways you can express the larger squares area. So because the sum of a and b squared is equal to c squared plus 4 times 1/2 ab, a squared plus 2ab plus b squared equals c squared plus 2ab. So a squared plus b squared equals c squared. This is his way of proving. So I want you to take a good look at this. See if you don't understand. Or you could rewind and watch the video again. Yep. So now that you've got it, let's move on to the next method. Actually, the conclusion. We use the puzzle method to combine the problem of shape with the problem of number and then perform integer operations. Number operations theoretically verify the Pythagorean theorem. Now this is Zhao Shuang's method. He was a Chinese mathematician. So here is what he did. He placed them like this, and let's learn about how he did it. So the area of this square right here, the large square, can be expressed as, so this orange square right here is c squared, or 1/2, which is 4 times 1/2 ab, plus the difference of b and a squared. So now we can solve this. So we know that they're both representing the same thing, so that's the equality right there. C squared equals 4 times 1 half AB plus the square of the difference of B and A. So 2AB plus B squared minus 2AB plus A squared equals A squared plus B squared, which equals C squared right here. So A squared plus B squared equals C. And this is Da Vinci's proof of the Pythagorean theorem. So right here there are two rectangles that are congruent. And out of it we're going to cut out a square with a side length of A and a smaller square connecting right here with the side length of B. Then we connect these sides right here, and this is labeled as shown. What he's going to do, he's going to take this and transform it so that you can see right here, this would be part 1, this would be part 2 of the aqua. You see right here, he labels this part 1, part 2. Then he transforms, so he actually flips part 2 the other side, and then you put them back together. So then this is what you will get. And this is the Euclid proving method of the Pythagorean theorem. As shown in the figure, draw a straight line AL across point A, right here. Maybe I should do my laser pointer. So right here, across point A to make it perpendicular to DE. Then cross DE to L and cross BC to M. By proving triangle BCF is congruent to triangle BDA, using the relationship between the area of the triangle and the area of the rectangle, the square ABFG and the rectangle BDLM are obtained. In the same way, square ACHK and rectangular MLEC have an equal product, so we can get AB squared plus AC squared equals BC squared. And as you can see, this is what's going on right here in angle A. Angle BAC is a right angle. Now, here's some discussion. Observe the figure below and use the method of counting grids. So you're just going to count the grids right here to determine whether the length of the three sides of the triangle satisfy A squared plus B squared equals C squared. So here's what we're going to do. You're just going to count how long each of these sides are and see if A squared plus B squared equals C squared applies to this. Are you done? Was it yes or no? So this might leave you thinking this is an obtuse triangle and over here is an acute triangle. Keep thinking. Why do you think it doesn't apply if it doesn't? Or if it does, why? The simple application of the Pythagorean theorem. Example 1. A spy agent Hart was investigating at a distance of 400 meters from the east-west highway and found an enemy car speeding on the highway. He quickly took out the infrared rangefinder and measured that the car was 400 meters away from him. After 10 seconds, the car was 500 meters away from him. Can you help Agent Hart calculate the speed of the enemy car? So let's do this together. So using the Pythagorean theorem, AB squared equals BC squared plus AC squared. So 500 squared equals BC squared plus 400 squared. The enemy car travels 300 meters in 10 seconds, and the distance it travels in 1 hour is 300 times 6 times 60, which is 108,000 meters. That is, it travels at a speed of 108 kilometers. Class summary. Exploring the Pythagorean theorem. We learned about proving the Pythagorean theorem and applying the proving process of the Pythagorean theorem to solve multiple problems. The two skills we worked on today was learn to use several methods to prove the Pythagorean theorem, is able to use the Pythagorean theorem to solve simple problems, And yeah, that's it. This is going to be the end of our first part in this chapter, the Pythagorean Theorem. And next time, we'll be digging deeper into, does it have to be a right triangle?